Now that we can express numbers in mod-arg form, I just want to have a look at some operations, starting with multiplication and division, then moving into taking powers. So I'm going to start by considering these two complex numbers in mod-arg form, Z1 and Z2. And I'm going to look at the product of those and see what happens. So I multiply the two together. Straight away I can see I'm going to have R1 times R2 out the front. And then I'm going to have to do a binomial distribution to the other two brackets. So use the distributive law. So what I'll do is I'll multiply the first ones together, and that'll give me cos theta 1 cos theta 2. Then to maintain the real parts of this number, I'll multiply the I signs together. That gives me I squared, which is negative 1, sine theta 1 sine theta 2. And then I'll start to multiply the others. So I'll go plus I sine theta 1 times cos theta 2 plus I sine theta 2 cos theta 1, finishing off the multiplication. So if you have a look closely, what we've got is we've multiplied the two moduluses together at the front, and inside the brackets we've got cos, cos, sine, sine. And if you recall from your extension 1 work, that was actually cos theta 1 plus theta 2. Remembering when it's minus cos, it's plus in there. And if you have a look at what we've got over here, we've got I sine cos and cos sine in terms of theta 1. And again, that is the sine sum of angles formula. So that's sine theta 1 plus theta 2. Now, if you didn't quite get that, carefully have a look over these and make sure you can recognise how these two here relate to that one there and these two relate to that one. Make sure you've got that. Because what that's basically done is provided me a really nice, easy way to multiply complex numbers once they're in mod-arg form. I can simply multiply the modulus together and then I can add the arguments. So for Z1 and Z2, multiply the modulus, add the arguments. For example, if I want to, if Z1 is equal to 4 cos I sine 2 pi on 3, and Z2 is equal to root 2 cos I sine 5 pi on 6, then to find the product Z1 times Z2, it's simply a matter of multiplying the modulus, so that's 4 root 2 cos I sine, and add the arguments together. So that'll be 4 root 2 cos I sine, multiplying those two together gives me 9 pi on 6, which is actually 3 pi on 2. Now just quickly having a look at this 3 pi on 2, comes around to here, 3 pi on 2. That's obviously not the principal argument, it's bigger than 180. So this angle back here would be negative pi on 2. And so I could rewrite this with the principal argument, 4 root 2 cos I sine, negative pi on 2. Both arguments are correct. This is just the principal argument, which is less than 180 degrees of in absolute value terms. So let's just move on to division. Now we know division involves us realising the denominator, so we have to have a look at the conjugate. So we'll start quickly with that. Just have a look at what the conjugate of this complex number will be. And so we know it's going to be cos theta 2 minus I sine theta 2. But what I'd like to do is rearrange this so it's in some sort of form that had a plus in the middle, because that would then allow me to apply the rules of multiplication that I just learned. And so to do that, I need to recall that sine of negative theta, in this case negative theta 2, will be equal to negative sine theta 2. And cos of a negative angle is simply the same as cos of the positive angle. So sine of a negative angle is negative sine of the angle, cos of the negative angle is cos of the positive angle. So this is what I've got in my expression. So using these as a substitution in lieu of these two, I get my conjugate is R2 cos negative theta 2, and then I can say it's plus I sine negative theta 2. So have a bit of a study of that and make sure you understand how these two expressions are equivalent to each other by using these as a substitution. And that way, when I go Z1 over Z2, which is equal to R1 cos I sine theta 1 over R1 cos I sine theta 2, and when I multiply by the conjugate, I can simply say the conjugate is this, which is R2 cos I sine negative theta 2 over R2 cos I sine negative theta 2. In fact, that should be an R2 there. Now these R2s are going to cancel, they're gone. So I have R1 over R2, and then now the multiplication process is nice and easy, I just add the arguments. So I get cos I sine of theta 1 minus theta 2 when I add that argument, over cos I sine theta 2 minus theta 2. So what really needs to be explored is this denominator here, because I've got cos I sine theta 2 minus theta 2. So just looking at this, that gives me cos of 0, theta 2, minus theta 2, plus I sine of 0, which is, just needs a quick explanation to make sure it's not 0, a quick explore. Cos theta is 1, sine theta is 0. So 1 plus 0i, in other words, is equal to 1. So my denominator is just 1. So in other words, I've ended up with R1 over R2 cos I sine theta 1 minus theta 2, which is a nice little result for division. It fits in with the multiplication result because now I'm dividing the modulus arguments. So there's my little rule for division in mod arg form. So if I take those numbers I had before, if I had Z1 was equal to 4 cos I sine 2 pi on 3, and Z2 was equal to root 2 cos I sine 5 pi on 6, then what I want to do to divide them, I simply want to divide the modulus, and I want to subtract the arguments. And so I'm going to end up, I'll rationalise that denominator, so I end up with 2 root 2 cos I sine. When I subtract this, I get negative pi on 6. So a really nice, easy division that doesn't take much time at all.